Hello everybody, my name is Mohamed Sadek and today we'll be looking at the PR interval. So now that you've learned how to do the rate, rhythm, axis, and look at the P wave, we're going to explore the PR interval. The PR interval is the duration from the beginning of the P wave to the beginning of the QRS, and it includes the P wave. So on ECG, it's from the beginning of the P wave to the beginning of the QRS, and usually it's less than or equal to 200 milliseconds, which is less than or equal to one large square. And what does a PR interval correspond to? It corresponds to right atrial and left atrial depolarization, followed by the depolarization wave reaching the AV node, where there's a period where there's no waveform on ECG. This is important because the AV node delays the transit of depolarization from the atria to the ventricle, and this is seen as the isoelectric component or flat line within the PR interval. The electrical signal now moves through the His-Purkinje system, and once ventricular tissue starts depolarizing, you start the QRS complex, the PR interval ends there. Now, why is the PR interval so important? Why is it important that there's a delay between the P wave and the QRS? Well, this serves multiple purposes physiologically. Number one, it allows the atria to fully contract and empty their contents into the right ventricle and left ventricle, allowing for mechanical association between the atria and ventricle. So atria contract, there's a bit of a pause, and then ventricles contract. And that allows emptying of the atria and filling of the ventricles. The second importance is this delay is associated with decremental properties of the AV node, meaning that the AV node will delay any impulse coming to it before reaching the ventricle. And this is important because if there's an atrial arrhythmia, such as atrial fibrillation, where the atriums are fibrillating or going very fast, the waves of depolarization don't lead to ventricular fibrillation or the ventricles going very fast. So this delay is very important to prevent the heart rate from climbing to very high levels, potentially causing loss of consciousness or death. So the PR interval is extremely important to delay the electrical depolarization of the atria from reaching the ventricles and slow things down. So now that we know what the PR interval is, let's look at a normal ECG. Here's an example of a normal ECG with a normal PR interval. And what I would encourage you to do is find the P wave that begins on a dark line, so the beginning of a large square, or a QRS that begins on a dark line or a dark square. That will make it easier for your eyes to see if there's PR prolongation. So this P wave starts at the beginning of the dark line, and if we zoom into it, we can clearly see that the PR interval starting at the beginning of the P wave and ending at the beginning of the QRS is less than one large square. So this is within the normal range. Here's an example of a prolonged PR interval. And if we look at the complex in lead V1 here, because the QRS seems to start at the dark line, we see that the beginning of the P wave to the beginning of the QRS is more than one large square. So this is an example of a prolonged PR interval. Now, when you read education materials or textbook, a lot of times a prolonged PR interval will be named first degree AV block. And it's important to know the terminology so you can communicate with other people about ECG findings. However, it's very important to understand that there is no true block. There is no block between the P waves and the QRSs, meaning that in a patient with a prolonged PR interval, every P wave is followed by a QRS, and every QRS is preceded by a P wave. It's just that the delay between the P wave and the QRS is longer than normal. So calling it a block is a bit of a misnomer, and I would encourage you to think of it as either prolonged PR interval or prolonged atrioventricular conduction. Here's an example of a longer PR interval. And here, if you zoom into one of the leads, it's clear, without even doing any measurements, that the PR interval is longer than a large square. This is an example of a very long PR interval. And here, if you zoom into this PR interval, it's longer than two large squares. So it's a very long PR interval. Now, there are some cases where it's tricky, where the PR interval can be so long that it's actually tricky to diagnose. Here's a case where the PR interval is extremely long. And it's long to the point where the P wave actually lands on the T wave of the prior QRST complex. And if you look at the rhythm strip on the bottom in lead 2, you can actually see the P waves marching through at different rates and separating at times from the T wave. Now, how do we know if these are truly P waves and not funny shaped T waves? Well, a T wave is usually very low frequency and smooth in appearance. However, P waves are sharper and more likely to have a negative deflection in lead V1. And if you look at the morphology of the T wave in leads V1, V2, you'll see that it's slightly abnormal and there's a negative notch within the T wave, which will help you understand that there's a P wave hiding within the T wave. And this is an example of an extremely long PR interval because the distance from that P wave to the next QRS is more than 2.5 large boxes. So in summary, the PR interval is the interval from the beginning of atrial depolarization So the beginning of the P wave to the beginning of the QRS, it includes depolarization of the atria, the transit of the signal through the AV node and the His-Purkinje system, and it's usually less than or equal to 200 milliseconds or 1 large square. Thank you very much, and I hope that was useful.